Hello everyone, in this video we will have circular functions. So let's start with the trigonometric points. But before that, let's review this one. Now special triangles could be a 45, 45, 90 degrees in which the two legs are congruent. In a 45, 45, 90 triangle, if one leg is 1, the other leg is 1, and by Pythagorean theorem, its hypotenuse is square root of 2. Okay, another. It could be a 30, 60, 90 triangle. In a 30, 60, 90 triangle, if the hypotenuse is 2, the shortest leg will be half of it. So if this is 2, this is 1, and the shorter leg will be square root of 3. So by Pythagorean theorem, this would be 4 minus 1, which is 3, and get its square root. Now take note, in a 30, 60, 90, the shortest side is 1/2 of the hypotenuse. So if the hypotenuse here is 1, then this would become 1/2. If this is 10, this would become 5. Now, going back to reference angles, for special angles, like 30 degrees, 45, and 60 degrees. 30 degrees, its corresponding standard angle in the second quadrant is 150 degrees, 210, and 330 degrees in the fourth quadrant. And since we're talking about circular functions, so we will be dealing with radian form. So 30 is pi over 6, this is pi over 4, and this is pi over 3. Now take note, for pi over 6 in the second quadrant is 5 pi over 6, 7 pi over 6, 11 pi over 6 in the fourth quadrant. Then for pi over 4, it's 3 pi over 4 in second, 5 pi over 4 in third, and 7 pi over 4 in fourth. So please take note of the pattern. Now for 60 degrees, it will be pi over 3, 2 pi over 3 in the second, 4 pi over 3 in third, and 5 pi over 3 in the fourth quadrant. Now going back to the 6 trigonometric functions, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, cosecant is hypotenuse over opposite, or simply it's the reverse of sine, and the reverse of cosine is secant, so it's hypotenuse over adjacent, and the reverse of tangent is cotangent, which is adjacent over opposite. Or you can deal with the very famous mnemonics so, ka, toa, cow, sha, sho. So take note, this is for sine, this is cosine, toa is tangent, cow is for cotangent, sha is for secant, and sho is for cosecant. Now take note, a trigonometric point is a point in standard form in the form xy, in which x represents cosine and y represents the sine value. Now, with that, so again, sine is the y value, cosine is the x value, and tangent is simply y over x. So, with the secondary functions, we will simply get its reverse. So, for cosecant, it will be 1 over y. For secant, it will be 1 over x. And of course, for cotangent, it's basically x over y. Now, let's have this one. If we will sketch a 135 degree angle, it will end in the second quadrant. If we will sketch a negative 60 degree angle, its terminal side will end in the fourth quadrant. Now, if we will sketch these two angles in a unit circle, we will get this one. So this is 135 degrees. So when you say unit circle, its radius is 1. So take note, going back to reference angle, if this is 135, so therefore this angle here would be 45 degrees. So take note, in a 45 degree angle, the two legs are congruent. So therefore, if it is 1, we will find the measure of this side and this side. So we will use the Pythagorean theorem. So x squared plus y squared equals 1. So since our x and y are equal, so we can have x squared plus x squared equals 1, or that's 2x squared equals 1. Divide both sides by 2. So we will get this and get the square root to both sides. So 1 over square root of 2. Rationalize this. So therefore, the value for our x is square root of 2 over 2. So since these two are equal, so therefore, the value for y here would be square root of 2 over 2. So therefore, the coordinate of point A here would be negative square root of 2 over 2 and square root of 2 over 2. Okay, why is it negative? Because from here, we move left and go up. So with this one, this is the trigonometric points. So the trigonometric point of 135 degrees is negative square root of 2 over 2 and positive square root of 2 over 2. So the same thing here. In a 60, 90, so therefore this is 30 degrees. So take note, in a 30, 60, 90, the shortest side is always 1/2 of the hypotenuse. So if the hypotenuse here is 1, so the shortest side here would be 1/2. Using the Pythagorean theorem, so therefore, opposite of 60 degrees here would be square root of 3 over 2. So with this, the coordinate of point B would be positive square root of 1 over 2 and negative square root of 3 over 2. So take note, this blue and this green, they are considered as trigonometric points of 135 degrees and negative 60 degree angles. So with this, take note, x is cosine and y is sine. So sine 135 degrees then would be square root of 2 over 2, while cosine is negative square root of 2 over 2, while tangent 35, it's basically sine over cosine, so therefore it's negative 1. You can always counter check this one with your calculators. So the same thing here. If we will derive the primary trigonometric functions of negative 60 degrees, or it could be 300 degrees. Negative 60 and 300 are coterminal angles. So sine negative 60, so the y equivalent here. So cosine negative 60 is 1/2, or it could be cosine 300 degrees, it's 1/2. And tangent negative 60 is negative square root of 3. Again, you can always counter check this one with your calculators. Okay, next. So these are, from here, we can derive the trigonometric points of the 6 circular functions. So for 30 degrees are pi over 6. So sine is 1/2 and cosine is square root of 3 over 2. Or its trigonometric points would be x and y. So square root of 3 over 2 and 1/2. So tangent is square root of 3 over 3. Cosecant is 2. Secant is 2 square root of 3 and so on. So the same thing for pi over 4, or that's 45 degrees. So we will get this. Sine and cosine will have the same value. Tangent and cotangent will have the same value. And secant and cosecant will have the same values as well, which is square root of 2. For 60 degrees, or pi over 3 and its multiple. So for sine here, square root of 3 over 2. Cosine 60 degrees is 1/2. Tangent 60 is square root of 3, and so on. So again, you can always counter check this one with your calculators. And the principle of getting this one is in the concept of trigonometric points. Okay, now take note here, the signs of the 6 trigonometric functions. So in the first quadrant, everything is positive. So all trigonometric functions are positive in the first quadrant. In the second quadrant, it's only sine and cosecant are positive, so the rest are negative. In the third quadrant, only tangent and cotangent are positive, so the rest are negative. And in the fourth quadrant, only cosine and secant are positive. So take note of this. And there is a mnemonics for this, which is the S, T, and C. So again, in the first quadrant, everything is positive. So the first S here stands for sine. In the second quadrant, it's positive. T, tangent. In the third quadrant, it's positive. And C, cosine. In the quattro quadrant, it is positive. Okay, so again, so all of these are derived in, or these are the trigonometric points of special angles. So 30 degrees, it's square root of 3 over 2 and 1/2. So again, this is cosine, this is sine. X is cosine and this is sine. So when you say cosine 60, it's 1/2, and sine 60, it's square root of 3 over 2. So if we will proceed in the third quadrant, when you say 210 degrees, or this would be sine 210 degrees is negative 1/2. While cosine 210 degrees, it is negative square root of 3 over 2. So again, in the third quadrant, both x and y are positive. In the first quadrant, both x and y, it is positive. So take note, this red trigonometric points here. So for 30, 150, 210, and 330 degrees, it is just the same because they are reference angles and the rest are corresponding standard angles in the different quadrants. Or basically, it's multiples of 30 in the different quadrants. So the same values, but the sign differ. So for 45 degrees, that refers to the blue values. While for 60 degrees and its multiple are pi over 3 and its multiple, it's the green trigonometric points. While the yellow ones, these are trigonometric points for special angles. So that's why you can always check in your calculator if you will say sine 90 degrees, that would become 1. And cosine 90 degrees, you will get 0. So take note of that. Okay, now we can identify the trigonometric points of special angles even if we will not use the calculator. You can make use of your hands. So just take note of this. For the thumb, that's 0 degrees. The index finger is 30 degrees. The middle finger is 45 degrees. And the ring finger is 60 degrees. And for the smallest finger would be 90 degrees. So take note, each finger corresponds to a certain angle measure. So take note, upper fingers represents sine, cosine, and lower fingers represent sine. Again, upper fingers represents cosine and lower fingers represent sine. So with this, for the upper values, that would always be square root of the number and always divided by 2. So let's take, for example, 30 degrees. So for 30 degrees, our point of reference is the index finger. Above the index finger, there are 3 fingers. So that would be square root of 3. So because it's 3 and over 2. So that would be for cosine 30. Below the lower fingers, it's only 1 finger. So that would be square root of 1 over 2, or that represents sine. Okay, another. What about for 45 degrees? For 45 degrees, above, there are 2 fingers. So therefore, that would be square root of 2 over 2. Below, which represents our sine, it's still square root of 2 over 2. So that's how are you going to do it. Okay. Okay, find the trigonometric points of the following. For number 1, this is 3 pi over 4, or this is multiple of 45 degrees, and 3 pi over 4 is located in the second quadrant, so the coordinates here would be negative square root of 2 over 2 and square root of 2 over 2. For number 2, negative 5 pi over 6 is a multiple of 30 degrees, and this is located in the third quadrant. So coordinates here would be negative square root of 3 over 2 and negative 1/2. Okay, next, for number 3, 7 pi over 3, this is more than one rotation. So with this, we will subtract 7 pi over 3 minus 6 pi over 3. Okay, why 6? Multiple of 3 that's nearest to 7 is 6. And besides, 6 divided by 3, it will give you 2 pi, which is exactly one rotation. So with this, you subtract, it's pi over 3. So coordinates then would be 1/2 square root of 3 over 2. Okay, next, for number 4, 25 pi over 3 is more than one rotation. So with this, multiple of 3 that's nearest to 25 is 24. So subtract 25 over 3 minus 24 over 3. And besides, 24 divided by 3, it will give you 8 pi. So therefore, it has 4 rotations. So with this, we'll end up with pi over 3. So coordinates then would be 1/2 square root of 3 over 2. Okay, next. Find the sixth trigonometric function of 13 pi over 4. Now, 13 pi over 4 is a multiple of 45 degrees. So with this, multiple of 4 that's nearest to 13 is 12. But in this case, we will subtract this with 8 over 4. Okay, why 8? Why not 12? Because it's like this. 8 divided by 4, it will give you 2 or 2 pi. But 12 divided by 4, it will give you 3 pi. It's not one rotation. So again, the one that you will subtract should always give you an even multiple. Why? Because one rotation is 2 pi and 2 pi is even. So 13 minus 8, it will give you 5 pi over 4, and this is located in the third quadrant. So coordinates is negative square root of 2 over 2 and negative square root of 2 over 2. So with this, sine 13 pi over 4 is the value for y, which is negative square root of 2 over 2. Okay, next. So the inverse of this is negative square root of 2. For cosine, so still positive, it's first value for x, so negative square root of 2 over 2. Well, secant is negative square root of 2. Then for tangent 13 pi over 4, it will give you 1. And the same thing for cotangent 13 pi over 4, it's also 1. Again, you can always counter-check this one with your calculators. Next. Now, at this point, give the values of the following. Okay, number 1. Okay, give the values of the following. Number 1, cosine pi over 3. The result here is 1/2. Sine 11 pi over 6 is negative 1/2. And sine pi over 3 plus cosine pi over 2. So the result here is square root of 3 over 2 plus 0, or simply square root of 3 over 2. Next, number 4, tangent pi over 4. It's 1 minus sine pi over 2. It's also 1, so the result is 0. Next, number 5, cosine pi over 6 is square root of 3 over 2. And cotangent 5 pi over 4 is 1. So the result here is square root of 3 plus 2 over 2. Next. Okay. The given point is on the unit circle. Find the missing value. So if the point is negative 24 over 25, and point A is located in quadrant 2. So using the Pythagorean theorem or the equation x squared plus y squared equals 1. So 1 because our radius here is 1. So our x here is negative 24 over 25 squared plus y squared equals 1. So simplifying, we will end up with y equals 7 over 25. So therefore, y in the second quadrant is positive. So the value for y then is 7 over 25. Number 2, the same thing. So negative 5 over 13y, and this point is located in quadrant 3. So using x squared plus y squared equals 1. So let's substitute. Our x is given, our y is unknown. So with this, you simplify. Our y is 12 over 13. Now take note, in the quadrant 3, y is negative. So therefore, the value for y here is negative 12 over 13. Okay, next. Find the 6 circular values given the condition sine theta is equal to negative 4 over 5, wherein theta is located in quadrant 3. Now take note, going back to this, x squared plus y squared equals r squared. So x squared, substitute. So take note, for sine, it's opposite over hypotenuse. So it's 4 or y over 5 squared, or r. So negative 4 squared 25, equals 5 squared. So 25 minus 16, so 9, square root of 9 would be 3. So since it is in quadrant 3, cosine is also negative. So our x then is also negative 3. So sine is negative 4 over 5. So reverse this. It will give you cosecant, which is negative 5/4. So cosine, adjacent, it's 3. Negative 3 over 5. So reverse, that would be for secant. So negative 5/3. And tangent, simply negative 4 over negative 3, or positive 4 over 3. And reverse for cotangent, it's positive 3 over 4. Next. Okay, graphs of trigonometric functions. So let's start with this. For the sine curve, so we have here your intersecting lines. So point of origin is 0. This is 1. This is 45 degrees, 90 degrees. This is 180 degrees. This is 270 degrees. And this is 360 degrees. Now take note, if you check in your calculator, sine 0 is 0. Sine 90 is 1. Sine 180 is 0. Sine 270 is negative 1. And sine 360, you will go back to 0. So with this, for sine 0, and sine 30 degrees, so 30 degrees, it's here, so it's 1/2. This is our 0.5. Sine 45 is 0.7. Sine 60 is 0.9. And sine 90 is 1. So this is basically first quadrant. In the second quadrant, so this would be sine 120 is 0.9. This is 135. Next is 150, and 180 is 0. In the third quadrant, this is 210, which is negative 1/2. 225 is negative 0.7. And sine 240 is negative 0.9. And sine 270 is negative 1. And in the last quadrant, or in the fourth quadrant, these are the movements of the sine curve. It will increase until 0. So take note. How is the graph obtained? It's basically the values of sine from 0 until 360 degrees, or it's simply one rotation. So for a clearer picture of this, let's have this one. Take note. The green marks, this is first quadrant, second quadrant, third quadrant, and fourth quadrant. For sine curve, it goes up in the first quadrant. It goes down in the second quadrant. And in the third quadrant, it goes down further. It's negative. And it goes up in the fourth quadrant until 0. That's the movement for sine curve. So, now, for an equation of a sine equation, y is equal to a sine bx. The a here stands for amplitude, or basically, it is the height of the curve. The B is the frequency, which is the number of cycles within 360 degrees. So take note, that's y is equal to a sine bx. Now take note, for sine curve, we have here the red graph. For cosine curve, it is the blue graph. So why it's like this? For cosine, cosine 0 is 1. If you try to check, cosine 90 degrees is 0. Cosine 180 degrees is negative 1. Cosine 270 is 0. And cosine 360 degrees is 1. So basically, it's the movement of cosine in one rotation, or in 4 quadrants. Now take note, for sine or amplitude, it's a. So here it's 1, that's the height. For frequency, it's denoted with f. To get the period, it's 2 pi over frequency. So whatever is the value for your frequency, so to get one period, so that's 360 over f. So to get the interval, so by the way, one period is this cycle. I, m maximum, I, m minimum, and I. So it's I, me for sine. So it's intercept, maximum, intercept, minimum, and intercept. Well, it's different for cosine. For cosine, it's mimim, maximum, intercept, minimum, intercept, and maximum. So to get the interval here would be period divided by 4. So this is always, this is 0. So first interval, second interval, third interval, or fourth interval. Or this is 0, 90, 180, this is 270, and 360. Okay, for the domains, so meaning it's the movement from negative infinity until positive infinity, because you can extend infinitely. So sine and cosine curve are sinusoidal graph. So it's also periodic. So after one period, it will go back to the same pattern. So that is sine curve. So the same thing for cosine. It's also sinusoidal. So it goes down, up, and so on. Okay, then for the range, it will start from the lowest point reached by the graph until the maximum height. So that's it. So for the pattern, for sine, it's I, me. If it's negative sign, it's I, small m, I, big M, I. For cosine, it's me. And negative cosine, just reverse the maximum and minimum points. Okay. Now, frequency is the number of cycles within 360 degrees. For a clearer picture of this dotted or this broken graph here, this is the graph of sine x. While the red graph, this is the graph for sine 2x. So what is the difference? For this 2 here, this represents 2 cycles. So within 360 degrees, there are 2 cycles for sine. While the black, it's only sine x, so there's only 1 cycle. So the higher the frequency, the more cycles would be within 360 degrees. That's the meaning of frequency. Okay, so this one. The first one is the graph for sine x. So meaning there is only 1 cycle within 360. And your amplitude, highest height and lowest height reach is 1 and negative 1. Then for this, it's 2 sine x. So the highest is 2 and the lowest height, it's negative 2. So this 2 here, it's amplitude. It has something to do with height. So in this case, so the same thing in the previous slide. So 2x, so meaning there are 2 cycles within 360 degrees. Okay, graph the following. Y is equal to 2 sine 3x. In this case, let's identify this one. The amplitude is 2, the frequency is 3, the period is 2 pi over 3, or that's 360 degrees over 3. The result here is 120 degrees. To get the interval, it's period divided by the constant 4. So that would be 30. To get the succeeding interval, just keep on adding 30 degrees. For the pattern for sine graph, it is IM. So graphing this, take note our amplitude is 2. It's negative 2 here. Our interval, it's 30, 60, 90, 120, and so on. Take note, you can extend to the right, you can extend to the left. So graphing this, we will end up with this one. So it's I, maximum, intercept, minimum, and intercept. So graph of y is equal to sine 2 sine 3x, we will end up with this. Okay, another. Graph y is equal to cosine 2x. In this case, the amplitude is 1, the frequency is 2, so the period here is 360 divided by 2, so it's 180 degrees. So the interval, 180 divided by 4, the result is 45. To get the succeeding intervals, just keep on adding 45. For cosine graph, the pattern is maximum, intercept, minimum, intercept, maximum. So graphing this, amplitude is 1, negative 1, interval is 45, 90, 135, 180. Take note, you can extend infinitely to the right and to the left. So graphing this, maximum, intercept, minimum, intercept, and maximum. So you can extend this farther. Now take note for the domains for graph number 2, it is infinite. So you can extend infinitely to the left and to the right. While the range will start from negative 1 until 1. While for graph number 1, the range here is negative 2 until positive 2. And the domains, it's still infinite. Okay, next. Now, for the secondary functions, like tangent, cotangent, cosecant, and secant, they are considered as non-sinusoidal graph. They are asymptotic, so at some point it is broken. That's why for tangent, the pattern here is intercept, undefined, intercept. So the undefined part here is the broken part. For cotangent, it's undefined, intercept, undefined. For cosecant, it's undefined, maximum, undefined, minimum, undefined. For secant, that would be maximum, undefined, minimum, undefined, and maximum. So graph of cosecant. So take note, cosecant is the inverse or reverse of sine. So this is the graph of sine. For cosecant, this will be its graph. So it's simply the reverse. If sine is going up and down, here this is going down and up. So in the second to fourth quadrant, sine is going down and up, while cosecant is going up and going down. So you can see here in the values here. So sine, cosecant, 0 is undefined. So cosecant 30 is 2. So it's undefined here. Cosecant 30 is 2. Cosecant 45 is 1.4. And cosecant 60 is 1.2. Cosecant 80 is 1.2. And cosecant 90 is 1. You can find it here. So cosecant 180 is undefined. So it's here. Cosecant 360 is also undefined. So take note, it's of the graph. So the red ones, it's the graph of cosecant x. Okay, so pattern for sine is I, me, me. For cosecant is U, M, U, M, U. So take note of that. The U stands for asymptotic. So take note of that. Okay, so graph for secant, it's the reverse of cosine. So cosine. So take note, secant graph, secant 0 is 1, so it starts here. Secant 30 is 1.5, 45 is 1.4, 60 is 2, 80 is 5.8, but when you reach secant 90, it will become undefined. So that's why it is asymptotic here. So start asymptotic here until cosecant 180 degrees is -1. So from 180 to 270 degrees, so meaning it is in the third quadrant. The values for secant is going down until infinity. Starting third to in the fourth quadrant, it is going down until +1. So pattern for cosine is MEM. For secant, it's MU. So for tangent and cotangent graph, so the red ones here, this is the graph for tangent. So tangent 0 is 0. Tangent 90 is undefined. So you observe here, from 0 to 90, the values for tangent is increasing. Okay, then from 90 to 180, the graph for tangent, it is increasing until 0. So from infinity, negative infinity until 0. Well, the graph for cotangent, from 0 to 180 degrees, or 0 to 90, from undefined going to 90, it is decreasing until 0. Then from 90 to 180, it is also decreasing infinitely until negative infinity. So note for the graph of tangent, it is like this, while the graph for cotangent, it is given as this one. For the period here, it is unlike for sine and cosine. For the period, it's 180 over frequency. The interval is period over the constant 2, and take note of the pattern. Okay, graph the following. Let's have sample graphs of asymptotic equations. So, for example, y is equal to 1/2 tangent 3x. So, let's identify its basic properties. So, the frequency here is given as 3. The period is given as 180 divided by 3, which is 60. For the interval, that would be 60 divided by the constant 2. So, we will have 30. Get the rest of the interval. So, that would be 60 plus 30 plus 30 and so on. For the pattern of tangent, we will have intercept, undefined intercept. So with this one, graphing this in the Cartesian plane, so although here when you say tangent, there is no value for the amplitude. So anyway, we'll just label this as 1/2 and -1/2. So the interval, so we'll get this. So this is pattern, intercept, undefined, intercept, undefined, intercept, undefined, and so on. Okay, so graphing this, so it will be going up. So you can extend infinitely up. So this one, go up and up. So here it's up. So this is the graph for tangent, 1/2 tangent 3x. Okay, next. Graph y is equal to cotangent 4x. So identify the frequency, it's 4. Period, it's 180 divided by 4, so it's 45. Get the interval. So 45 divided by 2, it's 22.5. Get the rest, 45, and so on. For the pattern here, it will be undefined, intercept, and undefined. So the same thing for tangent. The cotangent has no amplitude as well. So graphing this, so interval, it's 22.5 and 45. So this will be undefined here, intercept, undefined, intercept, undefined, and so on. So graphing here, we will have this pattern. So it's going down until intercept, then going down. So this is decreasing to 0, then decrease further to negative value. So one cycle will end at 45. Until the next, it's another cycle, and so on. And you can also extend at the left. Okay, next. Y is equal to 2 cosecant x. So let's identify its properties. So take note here for the amplitude, it will only serve as a guide. So amplitude here is 2, the frequency here is 1, so it's not written, so the default is 1. For the period, it's 360 divided by 1, or 360. Interval, it's 360 divided by the constant 4, so that would be 90. Get the rest of the interval, just keep on adding 90. For the pattern here, it's undefined, maximum, undefined, minimum, and undefined. So this will be for the sketch. So take note, this will be for the interval. So asymptotic lines will be at 180 and 360. So graphing this, so this would be undefined. This is maximum, undefined, it's minimum, and it is undefined. So take note, this is the graph for 2 cosecant x. And take note, cosecant is the reverse of sine. So graphing the sine curve here, this will be its form. Next, y is equal to secant 3x. So the same thing, let's identify its properties. Amplitude here is 1 because it's not written. Frequency is 3. The period is 360 divided by 3, so that would be 120. Interval would be 120 divided by 4, so it's 30. For the pattern, get the rest of the interval, so plus 30 and so on. So pattern here, it's maximum, undefined, minimum, undefined, and maximum. So sketching here, this will be for the pattern. So asymptotic lines will be at 30 degrees and 90 degrees. So sketching, this will be our graph. So take note, this is maximum, this is undefined, this is minimum, it's undefined, and here it is maximum. So take note, secant is the reverse of cosine. So graphing cosine here, this will be our graph. So take note of that. Okay, so that would be all. Thank you, everyone.